Okay, we're doing number 20 on page 311. So negative 2 secant 4x plus 2. Now we need to be careful because in the book it just says negative 2 secant 4x plus 2. Right? The plus 2, there's no parentheses. So, and the way the book does it is if they put parentheses, they'll put it around everything so it'll look like that. So if this plus 2 was inside of the secant function, then the parentheses would be around it. If there's not a parentheses around it, then it's outside of the function. And being outside of the function means that we do what? So plus on the outside of the function means up 2 in this case, right? If it was minus 2 outside the function, we go down 2. Okay? So here's my function. What is my amplitude? Absolute value of negative 2, which is 2. What's my period? How do we find period?
2 pi over b.
2 pi over b. What's my b value? All right? Okay, and we know that it's shifted up 2, positive 2, shifted up 2. Zoom in just a little bit. What does my parent function look like? So if I were to just kind of sketch out the parent function without all the shifts and the transitions, translations, all that, what would it look like? Well, we know that it has this here. There's asymptotes like right around here, and then there's the one that goes down this way. This should be, if I want to keep it symmetric to that one, it should be like this, and then there, and then here, then right, and continues on forever. That's what the parent function looks like. Okay, but we're shifted up 2, right? Everybody agree? We're shifted up 2, so that means that this point is going to go up 2. This point is going to go up 2. This point is going to go up 2. Every point on the graph goes up 2. The whole thing is shifted up 2. So now we got a general idea of what the graph will look like. We need to go ahead and start graphing it. Now the question wants us to do 2 periods. And my period is pi over 2. So what I'm going to do is just go ahead and go to pi. That would be 2 periods length. But my period may not start at 0. Now there's the formula in the book that tells us to find the starting point and ending points. We're not going to worry about that. We're just going to go ahead and go to pi. We'll graph, and if we need to add a little bit, or if we have a little extra, it'll be fine. Okay? So this will be pi right here. And what's half of pi? So this will be pi over 2. And what's half of pi over 2? Pi over 4. And I know that I'm going to need parts in between here. Okay? Just the way that we graph, if it was here, or if it's here, or over here, I know that I'm going to need in between points. So I need to go one more down. So this will be pi over 8. Okay? When I check on my calculator, I'll use my scale for the x-axis as just pi over 4, and that'll be fine. But to graph here, I need this intermediate value. So maybe. I don't know. We'll find out. We might have to go again. We'll see. We'll have to look. Once we start graphing, then we'll know for sure. So the first thing I'm going to do is try, I'm going to look at 0. So we plug in 0, 4 times 0 is 0. Secant of 0, we can use our trig sheet for this. So here's 0. Secant of 0 is 1. 1 times negative 2 gives me negative 2. Negative 2 plus 2 will give me 0. So at x equals 0, y equals 0. So I have a point there. All right. Now over here on the side, I'll go ahead and do one more. If you put this in the calculator and use the table function, pick x values that we're looking for, and you do the table function, you're not always going to get the asymptotes. It won't always say error. It might give you a very, 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 very small number, and it might not be easy to graph. They might give you, like, they're not going to tell you radical 2. They'll give you a decimal equivalent, or they'll have pi's in there. So I think the best thing to do is to do this by hand, just like in Algebra 1, when you set up an XY table, you picked an X value, you calculated the Y value. We can do that using our trig sheet, and this is good practice on the trig sheet anyways. So let's try the next one by hand. So y equals negative 2 secant of, let's do pi over 8 or pi over 4. Let's graph pi over 4. I want to do that one. So 4 times pi over 4 plus 2. And here the 4's cancel, so we have secant of pi. Secant of pi gives me negative 1. So this will be negative 2 times negative 1 plus 2. So this will be negative times negative is positive, so this will be 2 plus 2 gives me 4. So, I didn't do my y scale. I forgot about that. So let's do 2, 4, 6. And down here we'll do negative 2 and negative 4. So we have at x equals pi over 4, we have a y value of positive 4. Now let's try pi over 2. So we do y equals negative 2 secant 4 pi over 2 plus 2. So this gives me 2 pi. Secant of 2 pi is 1. 1 times negative 2 is negative 2. Negative 2 plus 2 gives me 0. So I have 0 here. What do you think? This will be pi over 4, 2 pi over 4, 3 pi over 4 right here. So let's go ahead and try that one. 4 times 3 pi over 4. That'll give me 3 pi. And secant, well, 3 pi would be 1, 2, 3. So that's the same as pi. Secant of pi is negative 1. Negative 1 times negative 2 is 2. 2 plus 2 would be 4. So I'm right here. So now I can start to see that I probably have this here and this here. So I want to find these in between values. So let's look at pi over 8. So we'll do y equals negative 2 secant 4 times pi over 8, which gives me pi over 2 on the inside. So we need to find secant of pi over 2. And that tells me that it's a what? Asymptote. So we have divide by 0, so that means asymptote at pi over 8. And so we'll have an asymptote at 3 pi over 8. And we'll have one at 5 pi over 8. And we'll have one at 7 pi over 8. Okay? So now I need to find this point here and this point here. So that would be pi over 16, 2 pi over 16, 3 pi over 16. So let's put that in here. 4 times 3 pi over 16. So that would be 3 pi over 4. So what I need to find is secant of 3 pi over 4. Well, what's the reference angle for 3 pi over 4? Pi over 4. Secant of pi over 4 is radical 2. So we know that the base number is radical 2. 3 pi over 4 is 1, 2, 3, quadrant 2. And secant is positive or negative in quadrant 2. So my answer is negative radical 2. So we have negative 2 radical 2. Negative, negative makes it positive. So this is 2 radical 2 plus 2. So what do you think we have? Yep, so this is going to be 4 points or 5, no, it'll be 5 point. Let's try it. So 2 radical 2, yeah, it should be 4.8, right? Plus 2 be 4.8. So almost 5. So that would be, right here would be 5. So we're like right there. And then symmetry would put us here at 5 pi over 16. And so we know that it's asymptotic, so I need to do a curvy line that's asymptotic. And right here, I'll know that this needs to be like 0.8, right? So it'd be just a little bit less than 1, so that'd be here and here, and it's asymptotic. And then the same thing here, asymptotic. And same thing here. Asymptotic. And that's our rough graph. Okay? Let's check on our calculator to see. Let's check on our calculator to see what the function looks like. So first thing we have to do, we have to graph it. -2, or type in our function before we can graph it. So -2. How do we do secant on the calculator? So 1 divided by cosine of 4x plus 2. And now before I graph, I need to check my window. What's the x min on my window? Right here that I have drawn on my graph, what's my minimum x value? 0. So I'm going to hit 0. What's my maximum x value? Pi. So I'm going to hit in pi. Of course, once I hit pi and hit enter, it will convert it to a decimal, which is fine. And what's my scale? Yeah, pi over 16 is the little ones here, but I think pi over 8 would be the better one, right? I don't need to see all the little tick marks. So let's do pi over 8. I think that'll be a little bit better. But you can do pi over 16. You can even do pi over 4. That might be a little bit too much of a, you're kind of having to guess too much in between there. But I think pi over 8 will be enough. And what's my minimum y value? Yeah, I have -4 drawn in here. You could probably do -2. Let's do -4. That's what I have on my graph. And what's my maximum y value? 6. Okay, and then my scale on my y-axis? I went by 2s, right? Okay. And so this is what your window will look like. And then you hit graph. And does that look like our graph? Well, we didn't do this one here, but does it look like it? Yeah, so then we know we did it correctly. Okay.